Hello guys and welcome to this video on electronic stability control system, and in this video I'm gonna explain it in detail, the ESC system architecture and how it works and how it performs and influence the behavior of vehicle on the normal road conditions. So let's start this video. So electronic stability control system is basically known by many other names like electronic stability program, vehicle stability control system, vehicle stability program, dynamic stability control, and some more. So starting with the sensors used in electronic stability control system, so we have lateral acceleration sensor, then yaw rate sensor, steering angle sensor. Basically these three sensors working in tandem with the other sensors like wheel speed sensor and other sensors incorporated in systems like electronic brake distribution, ABS, and other. So we have lateral acceleration sensor which measures the lateral acceleration of the car, and then we have yaw rate sensor. So basically if we want to see what yaw rate means briefly, so when we see this car, so its movement around the z axis, if we consider this as a vehicle, and x axis as the lateral axis and y as the longitudinal axis and z as the vertical axis. So when vehicle is getting a movement around the z axis, then we have yaw movement. So we call it yaw movement. So in this case, like we can see, if vehicle is moving around its vertical axis, so if we consider this as our vehicle and this as axis, so if vehicle is moving like this, so this is yaw movement. So this yaw rate sensor measures the yaw movement of the car. So in electronic stability control system, it basically comes into function during the situation of understeering and oversteering. So understeering, when the vehicle is taking turn less than intended, or the feedback or the we have done or the feedback from the steering system, the vehicle is moving less. So this electronic stability control system module sees how much the vehicle need to be turned, but it's turning less. So when we see we turn our steering wheel to some degree and the vehicle is not responding accordingly, it's still going in the straight line or going less than the intended path. So this red path over here is shown as the actual intended path, or the actual path it is gonna follow if electronic stability control system is not acting. But when ESC system acts, it follows the green path, which is the actual path it should follow. So the rear right tire or the rear right brake is actuated according to the sensing of the system and calculation how much compensating movement is required. When this wheel is locked or brake, the whole vehicle moves in that direction, or the compensating movement is acting in that direction, and the vehicle gets the path which it should actually get. If we see in the oversteering condition, so vehicle is turning greater than intended or greater than what we have moved or turned our steering wheel. So here the front wheel of the vehicle is brake, so compensating torque is acting in the opposite direction, and the vehicle goes in the actual intended path, which is the green path over here, and the red was it was actually following, which it should not follow. So here in the oversteering condition, the front wheel of the vehicle is braked and it is following this green path. So that's how electronic stability control system works briefly. And then if we go on the ESC system architecture, so we have road input. In some vehicles we have front cameras or the sensors which take input of the front road, and then we have driver inputs, how much he is turning the steering system, and then we have sensors. So in the steering system we have steering angle sensor, and then we have electronic stability controller, and then we have sensors on the vehicle like yaw rate sensor and the lateral acceleration sensor, which gives feedback from the vehicle or the input from the vehicle, and then the actuators as on the feedback required to move or turn the vehicle, it gives the braking force to the tire required, and in some cases it also tune down or make the engine power lower to the wheels in order to compensate the turns. So if we see or take a situation like this, if the vehicle is going on the road and something comes in the way and you are trying to turn it but it's not going to turn, so in this case it's going through the understeer condition where the right wheel is braked and the vehicle easily takes the turn, and when the turn is over and you want to come on the same lane again, so here the situation is going to be oversteering, so the vehicle is going to move or turn greater than intended. So here again electronic stability control system comes into act and it brakes the front wheel in order to make the compensating torque, and the vehicle remains on the intended path and the direction it is going to be. So I think it's enough for the stability control system as a brief, and if you like this video, please like the video and share with your friends who want to know about electronic stability control system, and please subscribe to my channel. Thank you.